All right, hi everyone. Larry Mussolino here. I wanted to record a short video to kind of go over some of the basics of week 4. And week 4 is all about quadratic functions. And I wanted to just remind you that when you come here to the week 4 learning materials, there are these excellent lecture notes and videos to please check out. So here is lecture part 1, part 2, part 3, part 4. Here's an Excel tutorial. This will be very helpful in your project and in the Excel lab for week 4, because this video, the Excel tutorial, will go over this idea of quadratic regression. What that means is you have a set of data points that really isn't a good match for a straight line fit, but the points might be a good match for a curved fit. So a quadratic function is a curved function. By the way, if I scroll down a little bit, so notice down here, there are some notes, this PDF file. I'll open this up so you can take a look at it. Please look this over. This has a lot of good information about working with quadratic functions. All right, well, let me just give you a little bit of background on quadratic functions. And for that, let me just go to the week 4 discussion. And I'm going to scroll all the way down to the bottom where I put some notes here. And so let me give you a little bit of background. So a quadratic function is one that has an x squared term. So here's an example. F of x equals x squared plus 4x plus 3. So the fact that there's an x squared term is what tells you it's quadratic. Now the graph, if you go to graph this, I'll show you the graph in a second in Desmos. If you go to graph a quadratic function, it's either going to look like a curve that opens upward like this, or a curve that opens downward like this. We call these parabolas. So the graph is a parabola. Well, there's an easy way to know if a graph opens up or opens down. It says here, how do you know if the graph opens up or opens down? It says, look at the number in front of the x squared term. If that number in front is positive, then the graph opens upward. So let me give you a quick example here. How about if this function was, let's say 7x squared plus 2x plus 9. I'm just making up an example here. But this number 7 is a positive number in front of the x squared. That's what tells you the graph will open up. But what if the number in front is negative? Let me give you an example of that. How about f of x equals negative 5x squared plus 4x minus 7. The fact that this number in front of x squared here is negative is what tells you that the graph is going to open downwards. All right, well, one thing we want to know about these graphs is, where is this minimum point located here? Think of this as like the bottom of the roller coaster. That bottommost point is called the vertex. If the graph opens down, then there's a point right here at the top of the roller coaster. That is the vertex for this downward parabola. So we'd like to know the xy coordinates of that point called the vertex. So let's talk about how you find the vertex. So let me go back to this example, x squared plus 4x plus 3. What I'd like to know is, what is the vertex? Now I know this graph opens up, we just mentioned that, and so this graph might do something like this, let's say. We want to know, what is this xy coordinate of this point down here called the vertex? Well, the first thing you do is you compare this function to a standard ax squared plus bx plus c. and you write down the matching numbers for a, b, and c. Now, in front of this x squared, there's no number, so I'm going to put my own number 1 here to make it clear that a matches up to 1, b matches up to 4, and c matches up to 3. I'm going to write that over here. So a is 1, b is 4, and c is 3 for our example. All right, let's find the x-coordinate of the vertex. So how do you find the x-coordinate of the vertex? Well, there's a little formula that says if you want to know the x-coordinate, take negative b over 2a. All right, I'm just going to plug in our example. Our b number was a 4, so that's going to be negative 4 on top over 2 times a. Our a number was a 1. Well, on the bottom of this fraction, 2 times 1 is 2, so this is negative 4 over 2. That's negative 2. So we now know this x-coordinate is negative 2. But we still want to find the y-coordinate. Well, really, our function is y equals x squared plus 4x plus 3. Anytime I know an x value, I can plug it into this function and get the corresponding y value. So I'm going to do it. To find the y-coordinate of the vertex, all you have to do is take the x value and substitute it into the original function. All right, so I'm going to do it. Our vertex was, our x value was negative 2. So I'm going to replace this x with a negative 2 here. And I'll just work this out. Negative 2 squared is positive 4. 4 times negative 2 is a negative 8. All right, how about 4 plus negative 8? That's a negative 4. Negative 4 plus 3 is negative 1. So the y-coordinate is negative 1. So this vertex occurs at negative 2, negative 1. All right. Another item we'd like to know for these graphs is what are the x-intercepts and what are the y-intercepts? So let me just write down vertex we already figured out as negative 2, negative 1. All right, let me write the function again. Y equals x squared plus 4x plus 3. By the way, remember, anytime you have a function with f of x equals x squared plus 4x plus 3, you can replace the f of x with a letter y because f of x and y mean the same thing, so they're interchangeable. All right, let's find the x-intercepts. Well, to find x-intercepts, you let y equal 0 in the original equation. So I'm going to let this y here be a 0. So that's going to get me 0 equals x squared plus 4x plus 3. All right, well, there's a couple of ways now I can solve this quadratic equation algebraically. I can either try a factoring method or I can use the quadratic formula. I think it's a good idea to try the factoring method first because usually that's easier than using the quadratic formula. But if you can factor the quadratic expression, then you can use the quadratic formula. But here I think we can factor it. So what I'm going to do is factor as x plus 3 times x plus 1. Now you can double check this is really correct by remultiplying these two parentheses together using FOIL. In that PDF file I just showed you a few minutes ago, it explains this FOIL kind of multiplication. And if you were to multiply the parenthesis x plus 3 times the parenthesis x plus 1, you would see that you get back to this original expression x squared plus 4x plus 3. That convinces me my factoring was correct. Now the next step is you take each one of these parentheses and separately set them equal to 0. So I'm going to take x plus 3 equal to 0 and x plus 1 equal to 0. Well, now I can solve each one of these equations. I'm going to subtract 3 from both sides here. That gets me x equal negative 3. And I'm going to subtract 1 from both sides here. That gets me x equal negative 1. So our x-intercepts are -3 and 1. I'm going to write as -3 comma 0, -1 comma 0. All right, last step is let's find the y-intercepts. Well, to find the y-intercepts, I'm sorry, the y-intercept, there's only one of them. Find the y-intercept, you let x equal 0 in the equation. So that means, here's the original equation, but I'm going to let x equal 0. So that's going to be 0 squared plus 4 times 0 plus 3. Well, that's 0 plus 0 plus 3. That's 3. So the y-intercept in our example is going to be a 0 comma 3. All right, let me go graph all this in Desmos and just see if our analysis really makes sense as we look at the graph. All right, so let me go to Desmos. And if you go to Desmos, all you have to do is type in the function here in Desmos. I can either use f of x or y in this Desmos command line. That's up to you. All right, let me come over here, and I'm noticing this vertex is -2, -1. Let me label these points, make it a little easier to see. So I'm going to put -2, -1. Now, in Desmos, you could just click this label, and it'll put the point there. All right, well, here's the x-intercept. This is the point where the graph crosses the x-axis. Notice it's -1, 0 there, and -3, 0 there. Let me put those points on the graph just so you can see those. Oops, -3, 0, and -1, 0. All right, the one other point we're interested in is the y-intercept. That's this point over here, 0 comma 3. Okay, so there are the points labeled on our graph. I'll mention one other item. In this example, there were 2 x-intercepts. So in this example, there were 2 x-intercepts. Right, here was one of them, and here was the other one. But you could have a graph that really has one x-intercept. Here's an example of a graph that has one x-intercept. It might touch the x-axis here at one point only. So this is one x-intercept. And it can also be that there's no x-intercepts because the graph could do something like this, doesn't cross the x-axis at all. So there's no x-intercepts. All right, I hope this is helpful as you're working in